Okay, so we're going to go on to question 6, which is a conditional probability question. So we've got 3 girls who train in the gym. Now, Dora is nice and easy to deal with because I know that. Let's start with a tree diagram for Dora. So for Dora, I know that she either trains or doesn't train. And Dora's probability of training is 0.9. So the probability she doesn't train is 0.1, and they're independent of each other. I've then got Tina over here, completely separate tree diagram. The probability that she trains is 0.8, and the probability she doesn't train is 0.2. Flora is Tina's friend. The probability that Flora trains on any given day is 0.7 if Tina trains on that day. So we're here, Dina trains, so the probability then that Flora trains is 0.7. The probability she doesn't train when Tina trains is then going to be 0.3. If Tina doesn't train, the probability that Flora trains is 0.4. So the probability that she doesn't train is going to be 0.6. Notice these are entirely separate tree diagrams, that Dora is unaffected by what Tina and Flora do. So I've got a Tina and Flora joint diagram over here, and I've got a Dora diagram over here. Well, the probability that all 3 girls train is the probability that Tina and Flora train, which is 0.8 times 0.7. That's the probability they both train, times the probability that Dora also trains. And that gives me an answer of 0.504. Part 2, the probability that 2 out of the 3 girls train. Well, I'm going to start by probability of not Dora, but both Tina and Flora, plus the probability that Dora does train, Tina doesn't, and Flora does, plus the probability that Dora trains and Tina trains and Flora doesn't. Okay, so the probability that Dora doesn't train is 0.1 times 0.8 times 0.7 plus the probability that Dora does train, which is 0.9, times the probability that Tina doesn't train, times by the probability that Flora does, plus the probability that Dora trains, Tina trains, but Flora doesn't. I'm going to just do some quick calculator work, and adding those all together gives me an answer of 0.344. For part B, it's asking me to do some conditional probabilities. So given that Flora trained, well, we know that the total possibility of Flora training is going to be, well, she either trains here, which is 0.56, or she trains here, which is 0.08. So the probability that Flora trains is 0.56 plus 0.08, which is 0.64. So the probability of Flora training is 0.64. So this is probability that all 3 trained, D, T and F all trained, divided by the probability that Flora trained. Well, we already know the probability of them all training was 0.504. Divided by the probability that Flora trained, which is 0.64. Which gives me a 0.7875, or 63 out of 80. For part 2, probability that both Dora and Tina trained. Well, the probability of Dora training is 0.9, the probability of Tina training is 0.8, so the probability that both train is 0.72. So here we've got probability of them all training divided by the probability that both Dora and Tina trained, which is 0.504 divided by 0.72. And that gives me an answer of 0.7, or 7 out of 10. Part 3. If Tina trained, so we know the probability of Tina training is 0.8, then the rest of them training, so probability of D, T and F divided by the probability of Tina, so it's 0.504 divided by 0.8, and that gives me an answer of 0.63, or 63 out of 100. The last one then just asked me if Tina and Flora are trained. So Tina and Flora are trained, which we know already is 0.56. The chance that Dora also trained is going to be the probability that all three of them trained. So again, probability of D, T and F divided by the probability that T and F trained. Probability of all three of them training is 0.504. divided by 0.56. Which gives me an answer of 0.9. Notice that actually I didn't need to do this calculation here. My 0.9 is the same answer that I got up here because in fact we know that Dora's training is independent of whether or not these guys train.